We will try to understand the physical significance of differentiation with an example. Let's say we have a bike or a car, and the car is moving linearly with respect, and its distance covered in time t is given by the equation, let's say something like 3t square plus t, where t is in the time and s is the distance covered by the car. The distance is measured in meters. So at time t equal to 0, the car is stationary, it has not moved, and the distance covered is 0. At time t equal to 1, the total distance moved is given by 3 into 1 square, 3 plus 1, it's s is 4 meters. At t equal to 2, the distance covered is 3 into 2 square is 4, 4 into 3, 14 plus 2, 12 plus 2, it's 14 meter. At t equal to 3, s is equal to 27 plus 3, it's 30 meter, and so on and so forth. Now if I ask you a question, what's the instantaneous speed of the car at t equal to 2 seconds? So we know that the speed of anything is given by distance covered divided by time taken to cover that distance. Now at the time of exactly t equal to 2, no less, no greater than 2, what's the exact time? We can find the average speed. For example, average speed between t equal to 2 to 2 equal to 3 would be given by velocity speed. Let's say we denote speed by v, that will be equal to the distance traveled between these two times, which is 30 minus 14 divided by 3 minus 2. It gives you 16 by 2, or an average speed of 8 meter per second. But what's the exact speed at t equal to 2, or exact speed maybe like t equal to 3? To do this, what you do is let's plot a curve of this graph. Uh, let's use this data that we have gathered to plot a graph. To do this, we take an x-axis and a y-axis. On x-axis we have a time, and on y-axis we have distance traveled t. At t equal to 0 we have distance 0, at 1 we have 4, at 2 we have 14, at 3 we have 16. So we see that the distance increases something like exponentially pretty fast with respect to the time. So to find the velocity, or its rather speed at t equal to 2, what we do is we take a point just next to 2, which we call as 2 plus h at t equal to 2, and this is the point at t equal to 2, and the distance traveled is 14 meters. At the point 2 plus h, its distance traveled will be slightly higher than 14, which we can find it by using this formula s, 2 plus h. So to find out what's going to be the speed at t equal to 2, it's going to be the distance travel at 2 plus h minus distance travel as 2 divided by this time in this duration h, when the limit of h approaches to 0. As we make this separation as close as possible, the speeds, and it's tending to 0, then the speed at this point and this point becomes almost equal, and that's the speed at t equal to 2. And if you recall, this is the definition of the differential. So we can represent this as the derivative of s at with respect to the time t when time is equal to h. Now as we know that this is the differential of 3t squared plus t with respect to t, and we need to calculate it at t equal to 2. Now we know that this differential is equal to um, the differentiation of 3t square will be 3 into 2 into 2 into t and plus 1 at t equal to 2. Its value becomes the 60 plus 1 at t equal to 2, which is nothing but 12 plus 1 13 meters per second. So you can see that this is one application where we can find the instantaneous rate of change of any particular variable at a particular given point of time. Now if you look at this, we could also have, let's say we do not know the formula of differentiation and all these things. We could also have done it like this. We know that s is equal to 3t squared plus t. We could find the distance at t equal to 2. We already seen that it's 14 meter. What we could do is we could find the distance travel at t point 1 2.1 and find the value of t, whatever it will be, something greater than 14 meter, but we can use a calculator to find it out and whatsoever be it. Then we can, let's say this call it s1 and this call it s2. We can use a calculator to find s1 and s2, and then the speed at t equal to 2, or the average speed between 2 and 2.1 would be s2 minus s1 minus s1 divided by 2.1 minus 2 is 0.1. This should come out to be fairly close to this value, the value that we found using the differentiation, but it won't be exact. And you can further go on refining this by finding the velocity at, say, between t equal to 2 and t equal to 2.01. This reduces the separation between the two times where we find the velocity, but it will be very close. So in this case the velocity will be s2 minus s1, where s1 is the distance covered from at time 0 to 2.01 and then divided by 0.01. So this value will be more accurate than this value, but still it won't be exact. We can, by reducing this distance successively, we come closer to the real value, but to find out the exact value we have to use the differential formula, which will give you the exact value. I hope that this clarifies this. If you have any questions, you can put it on comment. Thank you.